In this video, we're going to talk about the dependency inversion principle. The dependency inversion principle states that high-level modules should not depend on low-level modules, both should depend on abstractions. And abstractions should not depend upon details, details should depend upon abstractions. Let's understand this with an example. In most applications, compile time dependencies flow in the same direction as runtime dependencies. Consider a typical business application. We have a user interface that accepts input data from the user, and that data is validated according to business rules, and then the data will be persisted or stored in a database using some data access logic. So this is referred to as a flow of control. Notice the flow of control is indicated by the red arrows. They point from left to right. Now, this flow of control determines the direction of runtime dependencies. In our example, during execution, the book service class in the business logic layer instantiates a book repository class in the data access layer. This means that at runtime, the book service class depends on book repository. Now, as I already mentioned, compile time dependencies tend to flow in the same direction as runtime dependencies. So if we take a look at our example, we have the book service class that instantiates a book repository class in its constructor. This means that the book service class references the book repository class, meaning the book service class depends on book repository at compile time. So while our runtime dependency is from book service to book repository, our compile time dependency also flows in the same direction from book service to book repository. This violates the dependency inversion principle. So rather than having the book service class depend on book repository at compile time, we need to invert the direction of dependency so that the book repository class now depends on book service. But how do we achieve this inversion? As we already noted, according to the dependency inversion principle, high-level modules should not depend on low-level modules, both should depend on abstractions. So in our example, the book service class is high-level because it contains business logic, while the book repository class is low-level as it is concerned with data access logic. So we need to let both the book service and book repository classes depend on abstractions. The book service class should own and use the abstraction, while the book repository class should implement the abstraction. Let's see how this works. So we define an abstraction. This abstraction can be an interface or abstract class. So let's create an interface, say iBook repository, and we need to define a member that needs to be invoked by the consumer. The consumer in our example is a book service class. So let's define the add method. This interface needs to be owned by the book service class. So it should be present in the same project as a book service class or in a project that is referenced by the book service class project. Now we can remove this book repository object instantiation, and instead of defining a field of type book repository, we need to use iBook repository. And since the book service class needs to use iBook repository, we can define a constructor parameter of type iBook repository and assign it to the repository field. And we can mark the field read-only so that it is not assigned to anywhere except the constructor. There is another way to use the iBook repository type, which is to define a method parameter of type iBook repository and use it inside the method. But we'll stick with defining a constructor parameter. Notice the addBook method calls the add method of the repository object, but this time repository is of type iBook repository, not book repository. All that is left now is to let the book repository class implement the iBook repository interface. So what have we done so far? First, we created an abstraction called iBook repository and let the book service class use that abstraction. Plus, the book service class also owns that abstraction. And finally, we let the book repository class implement the iBook repository abstraction. So this way, we have inverted the direction of our compile time dependency. So our design now adheres to the dependency inversion principle. This works at compile time. But what about runtime? When the book service class needs to be instantiated, an object of a class that implements iBook repository still needs to be created and passed as argument to the constructor. Or if you used iBook repository as method parameter, an implementation has to be supplied as method argument when the method is invoked. This can be done either manually or by using a dependency injection container or framework. So for example, if you're using ASP.NET Core, we can use ASP.NET Core's built-in dependency injection container. So in the main method, we can say builder.services.addScoped, for example, and pass as generic arguments iBook repository, book repository. So this is like saying to the dependency injection container Whenever someone asks for iBook repository, provide him with an instance of book repository. So in our book service example, whenever the book service class is instantiated, an object of book repository class will automatically be supplied as constructor argument. So this concept is known as dependency injection, and if a dependency is injected in the constructor, it's referred to as constructor injection, and if it is injected in a method, it is referred to as method injection. In the next video, we'll revisit the open-closed principle that we talked about in the last video.